Hello everyone. Let's continue with question 21. This is a moment's question and they said that the bar is balanced and there are two forces acting on it. We have the 4 Newton force this side and the force F acting on this side. And this is interesting because both forces are acting only on one side of the bar because most of the questions you have seen before, the force, one of them will act on the right, one of them will act on the left of the pivot. But it is also possible to have forces only acting on one side. So when the question say that it is balanced, then we know that the clockwise moment in this setup and the anti-clockwise moment in the setup are the same. So let's carry on to find out what F is. So knowing that it is balanced, I will say that but before that, for each of the forces, it is a very good practice to write down whether they are clock or anti-clockwise. So this is pushing the bar up. If you're unsure, you just put a pen or a pencil, the same position where your bar is, and then you try to balance with your fingers placed here, and you push, and you'll notice that this will go this way. So this is anti-clockwise. And similarly for this one, when you pull it down, this will be clockwise. And the two moments are the same. So clockwise moment equals to anti-clockwise moment because why? It is balanced. So the clockwise moment is force times distance. And the force, I don't know, is F, right? So this is F. What is the distance? The distance is the distance between this force, I can actually draw it longer, and the pivot. So the perpendicular distance, so that is 10 centimeters. I could change to meters if I want, or I can use it as centimeters. But if I want to remain the distance as centimeters, then I must make sure that on the other side, this distance here and this distance here, they are both the same unit. So it can be both in meters or both in centimeters. So in this case, I can continue. But if you want to change all to meters, by all means, okay? So times 10 centimeters. The other side, it is 4 newtons. And I multiply. Now, this is when a lot of students will make the mistake. Maybe I just clean off all the rest first to make the diagram a little neater. Now, this is when a lot of students will make a mistake. They will take 4 and they multiply by 15 or 0.15 because this is the distance that they see. But let's not forget that when we talk about distance, it is between the force and the pivot. So this is the distance because the force is here, right? The force, the pivot is here. Okay, so it's actually 10 plus 15. So 10 plus 15, so that's 25 centimeters. Again, the reason why I didn't change is because eventually, if this is in cm, this is in cm, the equation can balance. But if you're unsure, then just change everything to meters, that's fine. Okay, so F will be equals to 100 Newton cm divided by 10 cm, then you get 10 newtons. So that's your answer here. Okay, so be careful about the substitution of distance because this is a very common mistake that students make. Okay, let's go on to question 22. 22 is on pressure. Now, force per, so what is pressure? Pressure, the definition is force per unit area and, sorry, the A is missing, force per unit area. And it means what is the amount of force that's acting on one unit area. So what is unit area? Unit area is 1 square meters. So B is the answer, is the force acting on 1 square meters of area. Can I remind you that the definition for the different terms that you learn, you have to be able to recite them. Okay, you have to remember what they are. Let's go on. This is a man sleeping on a bed of nails, and it says why is so he can be injured is pricked by one nail, but not when you sleep on a bed of nails because the nail bed. So when you are sleeping on a bed of nails, there will be many more nails touching your body. So it increases the contact area. And when the contact area has been increased, then what happened? Then the pressure will decrease because pressure is force over area. So when your area increases, the pressure will decrease. Just to also remind you, in this case, the force that's acting, pulling the man down, is actually the weight of this man, right? So the force that's actually acting downwards is actually the weight of the man. So this one has is constant, right? So the constant force. So the bigger the area of contact, the smaller the pressure exerted. So it reduces the pressure and therefore he will not be injured. Let's look at question 24. Question 24 is a question on, yeah, there are four glass blocks resting. The contact area and the weight are different. And which one will exert greatest pressure? So what we do is we'll work out the pressure for each of the glass block. So pressure is force divided by area. So in this case, the force is actually the weight of the glass block because the weight is pulling it down. So what I'll do is I'll take the weight divide by the contact area. So they are all different. So I have already worked out in advance for you. And then I get this whole answer. And the one which is the largest pressure is this one, 2y over x. Okay, the smallest is actually b because it's 2/3 y over x. So all of them have the y over x that's common. So we then look at the numbers in front. So C is the largest pressure. Let's look at question 25. Question 25 has given you the pressure and the contact area. Now, when students make mistake with this question, it's usually because either they forgot because they see the word pressure and then they just take 2000 divided by 0.024. So be very careful about the information that's given to you. So in this case, the pressure is given to you, the area is given to you, and then you are actually finding the weight, which is the force. So slightly different from what you have done before. So again, I'll start by writing down the formula F over A. The force is actually the weight. I do my substitution, and then another very common error is mathematically, when you're trying to remove this from the denominator, some students may make mistake there. So remember, if you want W, you move this over to the other side, so you multiply by 0.024. So you will get 48 Newton as the answer. Carry on to question 26. Question 26, this is clockwise. This is anti-clockwise. And again, this very important word that says balance. You have to look out for this word balance or look out for the word that says equilibrium or horizontal, because this will then tell you that this clock and anti-clockwise moment is the same. Okay, so let's carry on. The clockwise moment is force times distance. So force is 25, distance is 0.5. The anti-clockwise moment, the force is F, is unknown, but what is the distance? This is again like a little trap, because some students will write 1.1, some will write 2, but if you are careful, you will know that the force is here, the pivot is here. So I'm actually talking about this distance here. So that would be 2 minus 1.1, and then you get 0.9. Okay, so then F would be equals to 12.5 divided by 0.9, and you get 13.9 newtons. Okay, so be very careful with distance and make sure you get the right distance. Let's carry on question 27. Now question 27, there are two syringes here, and they are both filled with liquid, and you apply a force. The important thing is they mention is the same amount of force. So the force that you apply in both cases are the same. And what is different is the area. Okay, so this area and this area is different. You can see that P has a bigger area. So which one then has a larger pressure? Well, pressure is force divided by area. So as you can see, Q has a smaller area, contact area, so smaller A, and therefore because the force in both cases are the same, so then the pressure here for Q, the pressure is going to be larger. Okay, so C is the answer. So Q is the one that will push the water further, because with a larger pressure, this water can then move further. This water has a smaller pressure, so not so much. So you will find that, you know, when the water experience a larger pressure, uh, the water in this case can go further, right? So this one is a smaller pressure, maybe somewhere here. Okay, so C is the answer, where the pressure is larger because the area of contact is smaller. So with that, I finish all the MCQ question. You can continue to watch the next video for the structured questions.